All right, we are recording. This is lesson 3.3 for chapter 3, quadratic functions, for our grade 11 pre-cal honors class. And we're actually going to make use of page 22 for a change. You don't have to actually write the instructions down here. How about you just copy down the little questions? Tell me what numbers would go here and here to make a perfect square trinomial. If you need a quick refresher on what a perfect square trinomial is, go to the next page real quick. And remember that x squared plus 6x plus 9 is a perfect square trinomial because it would factor to x plus 3 times x plus 3, or, to put it more succinctly, x plus 3 squared, right? It has two identical binomials for factors. So if that you remember, I'll give you a minute. See if you can do these three. I'll pause the video so that people at home can try it. There's the instructions if I went too fast before. So again, I'll pause, give them a try. And we're back. Don't feel bad if you couldn't get C. I meant for it to be tough. Chances are in grade 10 we didn't have one like this. Before we get to the tough one at C, let's make sure we understand A. Let's make sure we really understand A. If I have x squared, you don't have to write this down, x squared plus 6x, plus blank, obviously there's lots of things that could go in the blank, and I could be factorable, right? Like the blank could be 5, in which case it's x plus 5 times x plus 1. The blank could be 8, in which case the factors would be 4 and 2. But it's only one possible answer that would give us the exact same two factors so that I can do that. So who got what that one is? The answer is 9, so that would be plus 3, which is the same one that was on the other page. So if you were paying attention to the other page, congratulations, you got that one. Here, this one you had to think for yourself. What did it end up being? It ended up being 25. And then this was x minus 5 squared. And at this point, I want you to notice what is the relationship between this number and this number to allow this sort of thing to happen. So one more time, what is the relationship between this number and this number? And a person in the back of the room has the answer. What do you think?
I think that 3, when we multiply by 2, should be 6x. And for the 9, we should multiply it by itself.
Okay. The microphone probably did not pick you up from there, so let me rephrase and restate that. 3 is half of 6, but 3 squared is 9. And that is the relationship. If you know this number and you'd like to know that number, all you have to do is take this number, divide it by 2, and then square it. And that would work. So that will work. I don't like the way I wrote that down. Divide it by 2, and then square it. So that is how I figured out that this is 25. I took negative 10, I divided it by 2, giving me negative 5. Negative 5 squared is plus 25. And then notice the relationship between this number and this number is that it just has to be a square root. But notice that if this is a minus, then that has to be a minus as well. So here's another thing that maybe you were told in grade 9 or 10, but in case you forgot, perfect squares don't have to be whole numbers. Right? Yeah, perfect squares include 1, 4, 9, 16, etc. But isn't 4/9 a perfect square? Because if you square root it, you get 2/3. So perfect squares don't have to be whole numbers. Decimals too. 0.25 is a perfect square. Because if you square root it, you get 0.5. Right? Perfect square is anything that when I square root it, I get a rational number, meaning a number I can write as a non-terminating, let me say that backwards. Anything that if I square root it, I get either a terminating or a repeating decimal, or if I square root it, I get a fraction. That's the better way to think about it. Anything I can express as a fraction is rational. So if I take negative 3, I take half of it, and I square it, what do I get?
2.25?
I don't I get negative 3 doubled, right? Or sorry, halved, I meant to say. Give me that back. Halved, and then square it. I would get 4/9. So the perfect square trinomial that I would get from here is x minus 2/3 squared. If you're not sure if that's right, you could always multiply it out. Let's square that. And that's, thank you very much. I just put it upside down. Can I have a mulligan on that? I should rewind the video. 3/2. Thank you, that's better. Making this 9/4. Thank you for noticing that I wrote it upside down. Let's double check that that works. 3/2 and 3/2. X times x is x squared. X times negative 3/2 is negative 3/2 x. Negative 3/2 times x is negative 3/2 x. And negative 3/2 times negative 3/2 is plus 9/4. So we got that part. We got that part. And then if I add those two things in the middle, negative 3/2 minus 3 more halves, think about that as negative 6/2, which is negative 3. Aha. It's true, it's true. So that is the right answer, 9/4 and 3/2. So that's the scoop on perfect square trinomials. And in your notes now for lesson 3.3, let's start with reading this together. If I would like to change any equation that's quadratic from its standard form to its vertex form, I need to be able to do what's called completing the square, meaning I'm going to try to make a perfect square trinomial. And that's what the first blanks are. A perfect square trinomial is a trinomial that can be factored into two identical binomials, like this one. And here's the same little activity we just did. If I told you this had to be factored into a perfect square trinomial, what number does k have to be? Well, k would have to be 16, so that this would factor into x minus 4 squared. And this k would have to be half of negative 5 squared, which is 25/4. So I guess I should say k equals. So that this thing factors to x minus 5/2 squared. So how do we determine this number? K is half of b squared. Always. How are we doing so far? All right, let's turn this standard form into vertex form. We're going to do it using these steps. Step 1. Step 1, make that little symbol go away. There we go. Step 1, move the constant term to the right a little bit so that you have some room between the x term and the constant. So here's what I'm saying. Basically, think of this thing like it has a gap, like that. Now, factor the coefficient of the x squared term from only the x squared term and the x term. So that's going to look like this. Now you can see why I needed that gap. I needed a space. And in that space, I'm going to complete the perfect square trinomial. What number could go in this blank that would make this bracket a perfect square trinomial? It's going to be positive 9. Half of negative 6, which is negative 3, squared. Anything you square that comes out positive. So negative 3 times negative 3 is 9. And again, the k term, if you want to call this missing term k, is this little formula. Half of this number squared. So the number is going to be negative 6 divided by 2 all squared, which is as someone just said, positive 9. Now, I want a positive 9 in this space, but here's the problem. I'm not allowed to change the equation I'm working on. It has to stay the same equation. So I'm actually going to add 0 to my equation. It's just that 0 is going to look a little bit fancy. I'm going to add 0. We need to introduce that constant of 9 to create the perfect square trinomial, but I don't want to interrupt the actual value of the equation or knock off its balance or whatever. So I'm going to add 9 and then minus 9 again right away. So it's going to look like this now. 2x squared minus 6x, and then like I said, I want plus 9 there. But if I minus 9 right away, notice that that's 0. So I didn't change the value of the equation any. Now, having said that, this is the number I wanted in the bracket. I kind of don't care about this number. This number needs to leave my bracket. Get out of my bracket, negative 9. You don't belong here. Careful, though. If I take the negative 9 out of the bracket, turn to the back of the page now, notice that what happens to it? Well, how about this? This number isn't really a negative 9. You're probably going, well, it looks like a regular negative 9, but it's not. It's actually 2 times negative 9. So if I take the negative 9 out of the brackets, it really looks like this. Does everybody get what just happened? I undistributed the bracket, right? I took the negative 9 out of the bracket, and now it becomes a negative 18, because inside the bracket it was being multiplied by a 2. Outside here, well, I had to multiply that 2 to get the 9 out of the bracket. And now I can collect a couple of like terms. And then I can factor my perfect square trinomial. And therefore, my vertex is 3, negative 7, which would have been harder to figure out had I just looked at the equation back when it was in standard form. Right? Back when it was in standard form, remember, you don't have to write this part down if you don't want to. It was originally the equation y equals 2x squared minus 12x plus 11. Now, we already had another way we could find the vertex, right? Remember, we looked at that the other day? The little formula, the x-coordinate of the vertex is minus b over 2a. So in this case, that would be minus negative 12 over 2 times 2. And 12 divided by 4 is 3. Hey, look, that's the vertex, the x-coordinate I got. And do you remember how do we get the y-coordinate of the vertex? Well, we'd have to pick up this 3 and run it through the formula. So let's see, that's 2 times 9, right, 3 squared, minus 12 times 3 plus 11. And that's, what is that? Ew, that's 18 minus 36 plus 11. Okay, well, if I do the math on that, I do get negative 7. But that's kind of more work, actually. This little method has 2 advantages. First of all, if the numbers get big and ugly, I don't have to do this arithmetic. And secondly, it gives me an actual equation instead of just a point. Right? It gives me the a value and everything. So it's a handy way to turn one type of equation into the other, to turn standard form into vertex form. All right, let's try some more. That was actually a harder one. Here's an easier one. You know what makes this first one a easier? Is that the x squared doesn't have a coefficient on it. Well, it does, but that coefficient's 1. There's no point in factoring out a 1. So for my first step, I don't have to worry about, or for my second step, I don't have to worry about factoring out a 1. I can just say, fine, just tell me what goes in here to make that work. All right, we've seen this one already. What completes that perfect square? 25, correct. So that would be minus 10x plus 25, but then right away I'm going to minus 25. And again, the whole point of this step here is that it means I didn't change my equation. It's still the same equation it was, because all I did was I added plus 25 and minus 25, which is 0. I added 0. That doesn't change anybody. But it looks different because now I can factor this first part into x minus 5 squared. And these two things are like terms, so that's minus 21. So I know that my vertex is the point 5, negative 21. And you know, I can double check what I'm doing with technology. If I were to bring over Desmos, I'll come back to that in a sec if you're still writing it. Okay, what was the first equation I just did? I did y equals x squared minus 10x plus 4, which is that lovely parabola right there. Let me scroll out so you can see the entire parabola. There we go. And I just completed the square and found that in vertex form, it is open a bracket, x minus 5, close bracket, squared, and then, what was it again? It was minus 21. And there we go. It's blue, it's red. It's blue, it's red. It's the same line exactly, even though they look very, very different from one another. What were the first two I did again? The very first one was y equals, let me go back a page here. It was 2x squared minus 12x plus 11. So that's this little parabola here. Let me widen that out a little. Oh, there, good enough. And what did I say it was after I completed the square? It was y equals 2, open a bracket, and then it was x, what was it again? Minus 3 squared, and then it was minus 7, right? And there we go. Purple and green. Purple and green. Joker colors. Purple and green. Okay, so let's keep trying these. Next one. All right, we're back to one that's a little tougher. I have to factor out a 3, leaving behind x squared. If you take a 3 out of this 12, what does it leave behind? Leaves behind a 4. And then don't forget the 16 I kind of booted over here. And now I ask myself, I say self, what's half of 4 squared? Oh, half of 4 squared is itself. That's cool. So I need to add a 4 in this bracket. But I have to cancel that value as well so that I don't change my equation. What am I actually minusing from the equation? And the answer is minusing 12, because this isn't really a 4. I know, it's cleverly disguised as a 4. It looks like a 4, but it's really 3 times 4. So to balance that out, I have to minus a 12 out here. Does the logic of that make sense to you? And then f of x would be 3. This thing factors to x plus 2 all squared. And if I minus 12 and plus 16, I get plus 4. So my vertex is negative 2, remember the opposite rule for that, and 4. And I don't know about you, but I think that's less work than the whole minus b over 2a thing, because especially once you get minus b over 2a, you have to plug it back into the original formula and do a bunch of arithmetic. I didn't have to do any arithmetic, and if I needed the equation for some other reason, like I needed to solve something else or find the x-intercept, set y to 0, I've got an equation to work with. The minus b over 2a thing doesn't tell me a right away. So I'd have to work out, you know, do I have this 3 the a, or do I have to change it? Thoughts? Where does the 4x go is the question. And the question is answered by its factoring. It's, here, let me get rid of that. It's x squared plus 4x plus 4. You open up 2 brackets and you do your grade 10 factoring, right? What 2 numbers times to make 4 and add to make 4? And the answer is 2 and 2. So that is how it factors, right? All right. Let's try another one. C. Here's another one where I'm going to factor out a number. So I'm going to factor out a 3, leaving behind x squared minus 2x And then I need to finish that and put a number here and a number here. What's that? You don't have a C and D? Well, you look at the next page in your notes. It's not there? Ooh, okay. So we have a difference between my notebook and the one the students are using. So is your next page simply you try? Oh, okay. All right. Maybe take out a piece of loose leaf then. I'll give you a sec to get some loose leaf out. And we'll just do a couple more before we hit the tough one that says you try. My bad. I should have copied for you more pages. All right. You weren't finished this one? Okay. All right, I'm just scrolling back. Student requested to go back for a sec. Everyone else take out a piece of loose leaf. Is that good? Everybody else take out a piece of loose leaf, and let's copy C. Okay, so get caught up to me, and then let's figure out what this one is. What would complete this perfect square? What's half of -2? Then take that answer and square it. The answer is +1. Now, did I really add 1 to the equation? No. What did I actually add? I added 3 times 1, which is 3. So I have to subtract 3 to balance my equation out and make sure that I didn't change it. So that would be y equals 3 times x minus 1 squared minus 4. Okay. One more, then I want you to try a tough one, but this one's tougher. Why is this one tougher? Well, you're about to see in a second. The b value I got to work with is going to be odd. If I start by factoring out the thing in front of x squared, well, first of all, I'm factoring out a negative. Haven't done that before. So that leaves behind x squared, and then what would be the next term? If you factor -2 out of +10, what do you get? And the way you think about factoring is the way you were taught to think about it in grades 9 and 10. You always think, if I were to multiply it out again, I'd get the original thing back. So the 3 is kind of not part of the problem right now. Stick 3 over there and ignore it for a minute. But what's left here once I factored out -2? The answer is -5x. So now I ask myself, I say, self, what two numbers, or sorry, let me say that backwards. What is -5 divided by 2 and then squared? And notice, because 5 is odd, I'm going to get a fraction. Don't work in decimals. Okay? Next week's test will even say your final answers must have fractions, no decimals. So here we go. Half of -5 is -5/2. If I square that, I get plus 25/4. Now, did I really add 25/4 to the equation? No, I didn't. I added -2 times 25/4 to the equation. And 2 goes into 4 twice. So I actually added -25/2. So to balance that, to make a 0, I'd have to add +25/2. And then we factor. And the way we factor is, you'll notice the factoring is actually really easy once you get the hang of it. You notice it's always x. If this is a minus, this is a minus. And I just have to square root this number. And I know that's the constant of the factor. Maybe the hard part is right here. What's 25/2 plus 3? Well, 3 is 6/2. So that's 31/2. So my vertex is 5/2 and 31/2. If I was actually going to graph this thing, I'd probably think in terms of mixed numbers, right? 2.5, 15.5. but I really don't go to decimals unless I was working on some sort of, decimalized graph paper. Like that stuff with the really tiny little green boxes, if you've ever seen that in physics class maybe. Even then, I don't know, fractions tend to be easier to work with than decimals. All right, your turn to try one. I'm going to let you, I'll pause the video for the people at home. Check that out. Okay, hold on. So give this one a try. We'll pause it, turn it back on once you've tried it. All right, we're back. So I have to factor negative a half out of these first two terms. Well, that one's easy. That's x squared. That was the whole point. We factored out negative a half because we want x squared to be just x squared. But what happens to this guy? Remember the minus 3, you wait over here. You wait your turn, minus 3. You get over there. Now, what happens to 10? And the way I think about it is, whatever I put here, well, if I multiply it by negative a half, I should get 10 back. Another way of thinking about that is, what number goes here so that half of that number is 10? So that has to be 20. But remember, it also has to be a plus 20. So this is minus 20x. Now I ask myself, what is half of this number squared? So half of this number is 10. 10 squared is 100. Now, did I just add 100 to this thing? Oh, no, I didn't. I added negative a half of 100 to this thing, which is negative 50. So to balance that out, I have to add plus 50. Is that what you were talking about when you said plus 50? You were already on that step? Sorry. Okay, so there we go. Now we can factor it. It's negative a half. And again, this part, all you have to do is look at this number is x. This sign has to be the same in here. And whatever the square root of that is your factor. And then there we go. We have a vertex of 10, 47. And that's my parabola. Okay. You can watch me do these all day. It's probably not going to make you much better at them. You'd think for all the hours I've spent watching hockey, I'd be the bestest hockey player ever, but no, it doesn't work that way. You have to actually try things to get good at them. So the next 2 pages are questions for you to try. We'll go over them in class tomorrow. It even says, come to class with these completed. We'll go over them first thing in class tomorrow. If, however, you finish all of 1 to 8, then there is a textbook assignment. I'll show it to you. It's on the blog. That's it for the video. Thanks for watching.